Hello and welcome to this quick look at a question from the 2021 OCR Unified Chemistry paper. It's focusing on explaining the differences in boiling points. So what's interesting about this question is it brings in electronegativity, which is not something that people generally associate directly with anything that affects boiling point. But because it's been included, you need to make sure you somehow use electronegativity in your thinking and your explanation. So it gives you the boiling point data for 3 compounds, and they want you to explain the difference in these boiling points. So I've put the 3 compounds at the right hand side of the screen. So this is where I'm going to try and use the electronegativity difference to connect that with what directly affects the boiling point, which is the intermolecular forces and their relative strengths. So putting the electronegativity values next to each of the atoms and working out the electronegativity differences, you can see there's a pattern emerging. And that pattern is that the electronegativity difference, as it increases, so does the boiling point. So for example, with methane, it's minus 161.5 as the boiling point, and the electronegativity difference between the carbons and the hydrogens is 0.4. With ammonia at minus 33.3, the electronegativity difference is a bit bigger at 0.9. And what's happening is the boiling point is increasing alongside that. If you look at hydrogen fluoride, the electronegativity difference is a massive 1.9, and therefore the boiling point of hydrogen fluoride is also much higher. So CH4 has the lowest boiling point because it's got weak London forces only. There's no hydrogen bonding or permanent dipole-dipole attractions. So this means there's less energy required to overcome or break those London forces. So with ammonia, it's the second lowest boiling point, as this time you've got stronger hydrogen bonds in place which require more energy to break the London forces in the methane. But what about the difference between NH3 and HF? They both have hydrogen bonds present, but clearly there's a significant difference in their boiling points. Hydrogen fluoride has the highest boiling point because these hydrogen bonds are even stronger than the ones found in ammonia. And this is down to the greater difference in electronegativity between hydrogen and fluorine compared to the difference in electronegativity between nitrogen and hydrogen in ammonia. So this is our mark scheme. I just thought I'd take a couple of moments to take you through it. There's quite a lot of things that are technically correct, but you're required to ignore. Now the reason for that is because none of them are directly relevant enough to the answer in light of the data provided. So they want you to analyze the data and use that to explain the differences in boiling points. So the 2 points to make are the relative strength of the intermolecular forces, because that directly affects the boiling point, and related to that is the relationship between electronegativity difference and boiling point, because the data to do so was provided. Okay, as always, thanks for listening. Until next time, see you soon.